All right, can everybody hear me in the back of the room? Yes, yes, yes. Okay, so I think we're ready to get started. So my name is Elizabeth Smith, for those of you who don't know me. And I try to be as involved in the PHP community as possible. One of the things I work on is called PHP mentoring. And what that is I believe that to be a good developer, you have to have people who you know, who you work with, who you learn from. So I want everybody to stand up because I know you're on a food coma. Turn to the person next to you, say hi, introduce yourself. So conferences are about is networking. Alrighty, so now everybody can say I met somebody at a conference, and later you should all go and have a good conversation with them over, a Coke or a beer or whatever you're drinking. All right, so I'm going to talk about security today. This is a beginner's talk, a wide overview talk, and this is going to be about security from a developer standpoint, right? So let's go a little bit about security and me. My first conference that I ever went to was in 2007, and it was actually a PHP Tech conference. And I went to one of my first talks, and it was given by a man named Chris Shiplett. And I was a pretty new programmer. I had been self-taught. And he sat down and was showing how vulnerable sites are. And this was before, widespread knowledge of cross-site scripting and cross-site request forgery and all those kinds of really, really bad security bugs. Anyway, Chris sat down, and he opened up his laptop, and he hacked Amazon.com in front of us as the group. This was in 2007. The hole has been fixed. However, those kind of vulnerabilities existed. And for me as a developer who had never thought about that ever, to see a big name site hacked in front of me was a total eye-opener to the fact that no matter what you do, you are always insecure. Right, so why do I talk about security? Because everybody knows how you make things secure, right? You filter everything, and you make sure that you keep things up to date. You use HTTPS because OpenSSL is so secure. And you always apply security patches, and you follow every letter of PCI compliancy, and that just makes everything magically safe. Isn't that what everybody says? Guess what? Everybody is stupid. Do we need proof of that? Well, we've had some really great proof just in this past year, right? And in fact, did anybody hear about what actually was released this morning about what happened on eBay? eBay was just majorly breached, and they just released that. So if you have an eBay account, right now go change your password. They released usernames, passwords, and your home address info. Luckily, they've changed from storing all their credit card information over to the PayPal side, otherwise you'd be totally screwed. But the point is, there have been these huge, huge things that have happened just recently, and the attacks are only getting bigger. And you have to remember that there's also Big Brother watching. Not only watching, they know about 0 days that exist and are not reporting them because they're using them for their own purposes. So what should you take away from this, right? Security is important, and security hacking is only getting worse. These should scare you. This was released from the Symantec 2014 Internet Security Threat Report. If you want to scare yourself out of your mind about what our world is built upon, go read this. It's free. You don't have to even register to read it. The one that scares me the most, I think, is the fact that 1 in 8 websites have a critical vulnerability. Critical means, yeah, we can get anything we want. So, I did consulting for a long time, and we'd build a site, and you get to the end of the project, and the client would go, now make it secure. Well, just add security on. It's secure, right? It's always safe. toggle the security flag on. That was always my favorite. Okay, so the problem is security may not be what you think it is. What's the definition of security? Well, if you go to Merriam-Webster or one of the other dictionaries, there are about 10 different definitions. I've shown the first 2 because they're the most common. But really in computing, security is the second one. Things done. What does that mean? That means it's a process. It's not something that is or isn't. It's a process. You can try and call it a state, but it's not a state in computing. Security cannot be added on at the end of the project. If you don't think about it at the beginning, preferably, you're going to be screwed. You can't have some checklist you go down, and then you know all your data is always going to be secure. You can't have one person on the team whose job it is to make sure everybody else does their job. You can't hire somebody to do it afterwards. I wrote this great app. I'm going to hire the security firm, and they're going to make it safe. It's not some tool or appliance you smack in front of your internal network, and suddenly, magically, you're safe. And it's definitely not a Boolean. And this is the biggest problem in security today and how people think of security. Do I have internet security? Is my website secure? Yes or no? What? So what is security? Okay, it's a process. It is you as a developer and everybody else on your team being paranoid with the tinfoil hats. And it is the acknowledgement that everyone will be hacked at some point. So you have to have things in place to take care of the damage afterwards. I don't care how safe you are. Unless you have a box in a safe with no connection or anything touching the outside world, you are vulnerable. And the sooner you admit that to yourself and your team admits that, the better your life will be. You cannot be safe all the time to all people, ever. What does help with security is habit. Building good habits about the things you do mean less trouble later down the road. Because if you do get hacked, it's some obscure thing instead of your fault because you did something really wrong. Now, security in computing is in layers, turtles all the way down. Okay? At the very top level, we have physical security. No matter how secure your website is, if someone walks into your data center and plugs a USB drive into that box, you're screwed, right? If you have physical access to the system, game's over. Keep that in mind. Then you have system security. This is your operating system, your updates, the things that run the computer. You have network, how it talks to each other. That's something you have to think about when you're talking about security. You have the actual application security, where I'm assuming you're all developers in here, right? This is our problem. And then you have the user system. And this is what a lot of people forget about. No matter how secure your website is, if somebody's browsing on IE6 on XP, you can't do anything about it, all right? Users are going to have insecure systems. Users are going to have insecure browsers. So, as developers, we need to go and look at the things in the application security level, things we can directly affect, and possibly things we can affect kind of in the other layers by what we do. Okay, you have to know your threats. If you don't understand how the ways they can get into your system, how can you do anything about it? You have to help with securing the network and the host and everything else. Often, these things are either beyond your control, but they're not necessarily beyond your input. Sometimes you have to be the loud, annoying voice saying, for goodness sake, upgrade PHP. And then finally, if security is not a part of the process, from the very beginning, when you decide you're going to write something, to the very end, when you're just having it ready to go for the user, if it's not part of the process, you will forget something. So it's the same as having some kind of a build process. If you're not like pushing the code somewhere and looking at it through a browser to make sure it runs, how do you know it runs? If you don't have security as part of your process, if you're not looking at it every step of the way, how do you know you're doing what you're supposed to be doing? And you don't. So let's talk about applications in general. At the end of the day, what you do on computers is flipping bits, ones and zeros. You're dealing with data. That data can be very minor and insignificant, like an anime web form, or it can be very, very important, like somebody's medical information. Those two things do not need the same kind of security. And I'm going to say something which people will have a fit about, but what you do, sometimes you don't have to worry as much about security. People are like, oh, don't tell them that, then they won't do anything. If I tell people that and the developer then decides he doesn't need any security, hopefully you'll fire them. Okay, so a little bit word of warning. I have a lot of checklists in this, but don't use checklists to make sure things are secure. I use it because I have 4 children and a Swiss cheese memory, and if I don't write things down and have a list, I forget. So the first thing you need to do on any site, whether it's written or whether it's to be written, whatever you're doing with it, is you need to know your data. What are you going to be storing? And you need to know where that data is coming from. Is it coming from a group of people, interns over here who are putting in movie data for, Fox Network or something? Or maybe over here you have somebody who's putting their information on LinkedIn from all over the world. Where is it coming from? You need to know who owns that data. This is a licensing issue too, but you do need to know. When somebody puts in their username or their password, who owns that data? When somebody puts in their credit card information, who owns that data? You need to know what kind of access level for everything. And this is something people forget. Is it confidential? In other words, not only who has access to it, but say your developers. Are they allowed to have access to it? Does it need to be archived? And finally, do we need this data? And this is the one, if you have a marketing department who tells you, I want everything on all the people who ever come to my site, tell them no, okay? The less data you can store, the fewer problems you will have with security. Sometimes it is better not to collect. I know, marketing people are like, but we want all the data, big data, we want to process it. Would you rather be sued? Sometimes it's better just not to collect that data. Okay, so you know what you're collecting, and you need to know who your users are. Who's going to be touching this? And you need to think of things outside of just who's my average user. You need to think of, am I attractive to some sort of hacktivist who is going to hack my website because I'm running a website to collect money for something? How many of you have heard about the ransom demands that are going around for large sites? Anybody here? There are a lot of websites where they're doing, they know you're making money. They know you're a big product. So they give you a distributed denial attack. And then they say, you have to pay us, X number of dollars unless you do it. Well, the other thing that's going around, which actually I've been called twice on, is a group of Indians who claim to be from Microsoft who are calling because my system has viruses on it. Like, really? And then they get you to install spyware and then charge you to unlock your system. Like, there's lots of things going around just for money. Here's what a lot of people don't think about. Will your competitors pay to have you hacked? A lot of will. So you need to be aware that maybe your users are fine, maybe you don't have a problem there. But if you're going up against a competitor who's a little more shady and will pay to have you put down in Google rankings or pay to have somebody try and steal your data to make you look bad, you need to take that into account. This one people don't think about. There are a lot of revenge attacks out there. You need to be kind of careful about how you fire people and the holes you leave behind. So you know your users and you know your data. Now you need to know your laws. And the reason I only put a link there is because I think at last count there were like 123 laws that are applicable for storing different data in the United States alone. Okay? A lot of people think that, oh, I'm not doing anything important, I don't need to worry about the laws. That's a good way to have somebody come at you just for the money. You do need to be aware of those laws. The more data you store, the more laws are going to apply to you. And people are like, well, I'm just doing this for fun, or it's just an open source project. It doesn't matter. You need to take the time, look at the laws, see the ones that apply to you. Okay, basically, the really dangerous ones are storing financial data, storing medical data, and data from any kids. Those are the three ones that there are laws and laws and laws and laws, because this is the United States and we like to make laws. And if you're overseas and you're doing business in America, a lot of these will still apply. Same way goes the other way. A lot of European companies have laws for things like cookies and privacy that you need to take a look at. So you know your data, you know your users, you know what laws you're going to have to deal with. So you need to make good decisions. And you need to do all these things for every project individually. And people are like, this takes time and money. If this takes more than a day, you really haven't done the research on what you're building anyway. Okay, so you're going to make good decisions because you know the things you need to follow. How are you backing up? How are we protecting things? What happens if we have a tsunami go over the data center? Whatever. And the big thing is, what happens if you derp? Humans are very error prone. And the other one that a lot of people forget is third-party stuff. What happens if you use Facebook for logins and Facebook goes down or suddenly stops working? Do you have some kind of a backup plan? Are your users going to sue you because they can't get into their information? You can't control your users. So if you've done all those things, the next thing you need to do is write it all down. There's a big problem in computing with something called tribal knowledge. Has anybody heard this term before? Few people? If it's not written down, it doesn't exist. That's a good law to make for anybody you develop with. If it's not written down, it doesn't exist. Therefore, write everything down. The great brain dump. Doesn't have to be pretty. Doesn't even really have to be proper English, although I tend to kick people who use like U and R in like documentation. Just really bugs me. The point is, if you don't have it written down, you don't really have any security plan in place. So some of you might see a lot of this stuff as being very familiar if you've ever heard of risk management. Anybody here familiar with that term and what it involves? You people, yes? So usually in risk management, there's somebody whose job it is to do all this kind of stuff. I'm going to say that you need to do it for yourself anyway as a developer. The problem is usually they're looking at it from a different viewpoint. Yours is the developer viewpoint. What are the things that I need to know for my job? Not necessarily, what are the things I need to know to save my company's ass if things go wrong? Two different viewpoints, two different things. It may be the same information, but you need to have it with your code in a way that you understand. And the team, if you work with a team, understands. So this is kind of like risk management, and that we're answering a lot of the same questions. But this is different because we're answering them from a developer standpoint instead of from a management standpoint. And finally, the last thing, okay? Practice makes perfect. Test all the things. I'm not talking unit tests. I'm talking take a day with your developers, give them each other's parts of the source code, and ask them to find the bugs. Hack it. Anybody of you, how many of you here were at the workshop for hacking? A few people? That's fun to do, to break other people's code. There are also some really cool things called capture the flag exercises. If you go look it up online, Wikipedia has a really good article on it. These are good things to take a developer team. So they learn to have a mindset of everybody's out to get me. This paranoia is a good thing. If you know how to hack it, you know how to plug the hole. The other thing is you really need to test your backup and recovery plan. This is the biggest thing people don't test. Oh, we have backups off-site somewhere. They go and get the backups, and they actually haven't been updated for 6 months. Oh, now we're totally screwed. Not only that, you need to test them on a regular basis. Even if you're just having an open source site, you know, you need to have some kind of a backup plan there too. Say you're running it on AWS or whatever. Are you backing it up somewhere else? Heck, even a Dropbox to dump an SQL? You need to have some way of getting to that data if everything catches on fire. And finally, there's always the problem of Murphy's Law. Anybody know what this is a picture of? This is the Fukushima reactor when it blew up. because it survived the earthquake, but it didn't survive the tsunami. You need to remember to yourself that no matter what you do to prepare for security problems, there will always be things that happen that you did not prepare for. Maybe you have great offsite storage and your backups are up to date, but they both got wiped out in a fire or an earthquake or whatever. Always think as though the world is ending. Not in a bad way, because then you'll be really depressed because you work in computer science and it's depressing. But you do need to have that mindset of what happens in the worst case scenario, and then what happens if that fails too. You can't prepare for everything. Nobody can. But you do not need to have the mindset of one level of anything is not good enough. But also remember, at the end of the day, everything is a balancing act. We're in computing, right? Everything is payoff. Context is always important. You ask somebody which is the best way to do things, and what do they answer with? It depends, which people usually hate to hear. But that is the reality of life. There are too many variables. I cannot give you a 1 or a 0. The world doesn't work the way computers do. They do not read in 1s and 0s. If you run a bank website, you better be getting penetration tested on a regular basis. If you run an anime website, who cares? That's why I say less security, not no security, goodness. But you never want to be paying out the butt for great big security penetration testing and things like that if the return from that is not as great, right? You have to balance what is important for what you are doing at the time. Whatever your context is going to apply. And the other big thing you need to remember is you cannot be responsible for user stupidity. So as a developer, you need to be security minded. Doesn't matter if you don't have a lot of say in some of the decisions that are made. So this whole next part, I'm going to talk about things that'll make you as a developer have good habits in the things you are developing, coding, writing, dealing with on a regular basis. So let's talk about that first layer, the physical layer, right? Most people here, unless you're actually the one picking the data center or AWS or whatever, you're not going to have the decision to say, this is what we should have for physical security, right? But on the other hand, you kind of need to know where you are and what you're doing. If you're hosting on AWS, you kind of need to know what data centers are all your boxes in. And what happens if, like, the East Coast goes down? Do I know how to deploy it somewhere else? Some of that's taken care of automatically. What happens if AWS goes down? Do you have a backup plan? Guess what? AWS goes down. So does Azure. So does every cloud service at some point. Facebook stops hosting logins. GitHub goes down and all the developer community goes, oh my God, I can't get any work done. You need to have a backup plan. The other thing is, even though you're a developer and you may not get to make these decisions, it's good to have knowledge of what are good providers and what are bad providers. So when your boss comes up and says, I know this really good colo place, and you're like, really, we should go with somebody who knows what they're doing. So below that, we have the system layer. Again, unless you're in DevOps, this is usually somebody else's problem. On the other hand, you need to know what you're doing. You need to do your research. You need to fight for updates. And this is a big problem, especially with PHP updates in general. Oh no, it'll break my code. Well, that's nice. Hackers are going to break your code too. Which is more important to you? And in many ways, I blame this on developers. They don't like to hear that. All right? It's actually not that hard to get the code running on a different system. The first place I worked had a whole code base written in PHP 3. That code base is running on PHP 5.6 beta right now. It's just a matter of willpower, and the diff is actually only about 20 lines. You'd be amazed at how little you can do if you don't worry about all the Easter eggs filling up your logs. Because there will be a lot. Sometimes you have to, okay, we just want it to run. It's okay if it's throwing streaks and warnings and notices everywhere. It's still working. It's not failing. So beyond that, we have the network layer, how computers talk to each other. Everybody here know what Wireshark is? If you people don't know, if you don't know, please go look it up. If you don't know how TCP/IP works, come to my sockets talk on Friday. I'll teach you. You need to know some of the basics of what you are doing for a living. If you're writing for the web, you need to know how the web works and what holes there are underneath the web that you need to be aware of. And the biggest reason for that is so when the crazy boss comes up and says, okay, we moved all the databases to this other subnet. We just want you to open a socket to it and talk to MySQL that way. You can laugh hysterically and say, not without a nice encrypted VPN tunnel, because you really shouldn't just be willy-nilly passing all your database stuff across the system. That's just bad. And a lot of this puts the onus on you to learn about what you're doing. But if you're not willing to learn how to learn, you're not going to have a very happy developer career. Because computers change so fast. There's always something new to learn. I generally take an hour every morning, and that is my learning time. I sit down, I read what's new, I learn something new, code something new. That's a good habit to get into. Because eventually, we're all going to be obsolete in doing something else. I guarantee it. So we have the network layer, and then we get to the application layer. And for developers, this is usually your problem. How many of you have heard that line from somebody saying, oh, we just got to get it out the door? Really? If you as a developer think that not doing anything security-wise is going to make you code it faster, you're stupid. I mean, I hate calling people that, but really, security should not make things that much slower to write. You should already know those things in your head. Oh, I know that when I echo something, I have to escape it first, right? Why should that take any longer than just typing echo? If you have those patterns built up in your vocabulary of coding, then it doesn't take you longer to write secure code. But how do you get those good habits? It takes 30 days to build a good habit, okay? 30 days. For 30 days, you have to think to yourself, every time you echo something in a template, I must escape, I must escape, I must escape. Put it in a Post-it note on your screen. After 30 days, you've built that habit. And the next time you go writing code and you're writing stuff in templates, you do it without thinking. That's what habits are. They take the hard part, the thinking part, out of what you're doing. So, first of all, we must become paranoid. Everyone is trying to hack you. Doesn't matter how small you are. So there are really two kinds of bad things that happen in applications with security. One is caused by stupid users, and one is caused by evil users. Problem is, as an app developer, you don't know which are which, so just assume they're all evil. I used to say, imagine they're evil monkeys typing on typewriters, but my friend Keith Casey says that's specious. He has a thing for monkeys. Anyway, we all know cats are evil, so just think of all your users as evil cats, right? They're typing on the keyboard trying to get into your stuff. It isn't paranoia if they are out to get you. We need to know your attack vectors. These are the biggest attack vectors for any application. These are the places people are going to try and poke holes and get to your stuff. These have been around since computers started. Every single one of these was in code written in C in 1979, code written in COBOL ages ago. The attack vectors have not changed. How they're exploited really hasn't changed, which is why some people get sick of security talks, because often it feels like we're saying the same things over and over again. Guess what? We are, but people still do it wrong. So you have to keep preaching until they've built the habit so that you don't have to go beat on the junior dev who put a big cross-site scripting hole in your site. How many of you have heard of OWASP? Oh, that's good. These are the OWASP top 10. This was updated in 2013, The last update was 2010. And what they do is they look at all the hacks, basically, that happen on web applications all over the internet, and they rank them. And this is the top 10. Now, if you look at the slide just before, I'll have my slides online later, so you'll be able to look at them. But if you look at the two lists, they're scarily similar. Guess what? What you're hacking hasn't changed. It's the same kind of protections. So let's start with the first one, input validation. How many of you have heard of FIEO, or filter input escape output? Anybody here? That is horrible. I'm going to tell you that right now. And this is why. Filter is a very overloaded word in computing. How many different uses of filter have you heard of? Like, what they're really saying is validate input, escape output. And I'm going to push till this catches on, because the filter thing's driving me nuts. Okay? Validate. Make sure it is what you think it is. Now, all these things that OWASP talks about as top 10, the injection, cross-site scripting, unvalidated redirects and forwards, are all examples of when input was not validated and or not escaped. So what do you need to do in your mindset for every piece of data you touch? Make sure you get what you're expecting, always. Do you know what happens in PHP if you turn a get variable into an array instead of like an integer or whatever? Did you know you can do that? Just change the query string. Did you know you can cause some really evil hacks in some well-known libraries doing that? Because they don't check properly for types? When I say make sure you get what you expect, I mean all the way down the line. You need to check the type and the value, not just the value. You cannot assume anything, as in the case of the array thing. You cannot assume that somebody didn't send you something really malicious. And always be aware of context. So escaping comes with context. What do I mean by that? The way you escape data needs to change depending on what you're doing with it, right? So if I'm taking data and putting it on the screen, and it is an attribute for the color in a row, my escaping needs to be different than if I'm putting that data in a JSON variable that I'm sending off somewhere, right? Where your data goes changes how it's escaped. A really good example of this is actually in Zen Framework 2, if you just want to go look at it. They have an escaper class, and what they have is a bunch of different ways to do escaping for if you're putting that data into CSS, or you're putting it in a JavaScript, or you're putting it in HTML, or you're putting it in JSON. A lot of people are like, one size fits all, HTML entities, that fixes all your problems, right? No. If you escape something for HTML and put it in XML, it's going to break. Know where your data is going, because where it goes is going to change how it's escaped. So here are some best practices to cultivate. How many of you use like PHP as a templating language? Anybody here? A few people? How many of you use like, what, Twig? Mustache? A few people? Anybody here still using Smarty? I'm sorry. You really need to be careful, especially if you're using PHP as the templating language, that anytime you echo anything, it needs to be escaped. I'm going to pick on Zen Framework 2 a little bit here. So early in Zen Framework 2, they were going to do something they called auto-escaping, so that any variable you put into a template class would be escaped before output. And it was shot down for the fact that you shouldn't auto-escape anything, it should have context. Can't argue with that, but there's no reason you can't force the context when the parameter is put into the template. The resulting problem is that anytime you echo anything in a template, you have to remember to escape it first. How many people remember to escape every single thing they ever echo ever? Nobody. In fact, I did that recently and smacked myself over the head and wrote an auto-escaper into the template because it was driving me nuts. It is always better to whitelist than blacklist. This will come up in about 5 other slides here. Do not blacklist anything. That is the #1 way to get yourself hacked. Blacklisting assumes you know the bad stuff they're going to give you. But a hacker's job is to come up with new and shiny bad stuff, and you can't ever keep ahead of them. So the solution is to whitelist. This is the stuff that'll get through. How many of you use prepared statements? Oh, please, every hand should be up. If you use the MySQL extension instead of MySQLi or PDO MySQL, go home and rewrite that tonight. Seriously, it's search and replace. Do it. It's dangerous. It's also deprecated, so it's going to be really loud at you lately. How many of you use MongoDB? How many of you assume you're safe because you use MongoDB? You know, you can throw injection stuff in there really great. One thing I do with any developers I work on who do MongoDB stuff is use single quotes for everything. And the reason I say that is what happens if you have a $ inside double quotes in PHP? It's going to interpolate it. That can be really, really bad. Make yourself safe. The other thing is I always say to force validation. I think superglobals are one of the most evil things that were ever put into the PHP language. Oh, they're immensely useful, but they're immensely big holes. You should never, 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 ever touch anything in environment, in server, in post, in get, in session. Nothing is safe. The sooner you get that into your head that nothing is safe, the happier you will be. Nothing is safe, not even the server variables. What if somebody has managed to get an account, maybe not even a root account, but managed to set an environment variable that injects bad stuff into a server variable, and then you run your PHP and assume it's safe? What are you? Screwed! Yes. Never assume anything's safe. The other thing I'm going to tell you is use a good library. Everybody likes to write their own framework. I'm going to be the first person to say everybody should write their own framework, at least once, and then generally throw it away. It will teach you many things about good architecture, the things required, but on the other hand, having something that's maintained by many people, sees many eyes, has many fixes, you'll be a happier person. How many people here write your own email or URL validation? Anybody? Thank goodness. Use the built-in stuff. The PHP filter extension actually has regexes there that are looked at by many eyes and used by many people and fixed on a regular basis. If you're upgrading PHP, which you darn well better be. All right? More eyes, less holes. Rolling your own is usually a recipe for a big Doge dog on your site or something by somebody. Oh, look, I hacked your site today. So next we're going to talk about authentication. Session handling, password management, CSRF. How many of you here use PHP sessions for the most part? Yes, a few people. How many of you use a library on top of PHP sessions? For goodness sake, please do. There are some severely broken things that PHP does with sessions that a good library is going to take care of for you. Sessions are really, really hard. Why are they hard? HTTP is what? Stateless, stateless. Sessions are a hack. Oh, I don't know, computing never uses hacks. Sessions are a hack to be able to link different requests together. That's all they are. The sooner you get that into your head as you're coding, the happier you will be. Okay, and a lot of people are like, well, we'll just outsource this to third parties. They'll take care of it for us. You've usually introduced more problems than you solved. Now, there are a lot of different ways that authentication can be hacked. One is called network eavesdropping. There's brute force attacks. There's dictionary attacks, cookie replay, credential theft, session hijacking, session replay, and man in the middle. Those are just a few. There are lots and lots of ways authentication can go wrong. So even if you do all your best practices, if your network's insecure and your system people don't want to hear about it, I'm sorry. You should be yelling at them, though. This is why I tell you to use a good session library. There's a lot of stuff you should be doing that PHP does not do by default. How many of you here know what session fixation is? I'll explain it a little bit. What that happens is, so somebody sends you a link with a session ID, and they're basically going to steal it from you. That's the really, really simple explanation. There's some really good articles online. I have like 5 pages of resources at the end of this, so you'll be able to find the information you need. The other thing it takes care of is timeouts. PHP sessions will last until the garbage collection runs, except that in many distributions, that's kind of broken. So sometimes it doesn't run at all, so your PHP sessions last forever, which is awesome. The other thing it takes care of is things like encrypted connections. How many of you here know about using HTTP-only cookies? What that is it's a flag you send to PHP, which it sends when it sets your session cookie that says, I may touch this, JavaScript may not. There are lots and lots of dirty hacks you can do with JavaScripts and cookies. So if you are using cookies for anything more important than like, I like to save the color of the website, don't. Cookies are horribly insecure, and there's really no way to make them secure. Use them for non-important information or information you don't care if it's stolen. How many of you know about PHP's new password hashing APIs? Few people? Anybody here using them? You should be. If you're on a PHP version that doesn't support them, there's actually a PHP library. It's a little bit slower, not quite as secure, but it's pretty darn close. Better than anything you're going to roll by yourself. So use it. And then finally, something a lot of people forget is brute force attacks. What does that mean? Well, you need to have something in place. So if somebody goes to your website and says, oh, I'm going to try to log in with my dictionary. Ding, 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 ding. If you don't have some kind of detection in place for that, eventually they're going to hack your site. Computers are too fast now. The little thing I carry around with me every day has enormous power. It's really easy and really cheap to buy a botnet to attack somebody's site. You can't ever say, well, it would be too hard to dictionary crack this. It's never too hard. Somebody can always come up with the resources to do that. Next is authorization. This comes into white versus black listing. So what you need to do on any site is to give people the least access possible and then whitelist them into new access. A lot of people instead try to block things off. Oh, you're not allowed for this. That's a good way to have trouble. The other thing is you really need to do testing. I think Grumpy's giving a talk on testing. You should go to it. Testing is very important for this. This is one of the hardest things to make a habit, good authorization practices. Because without proper testing, you're not really going to see the places where people can get to the data when they shouldn't. So I'm going to tell you again, use a library. There are really good authorization libraries out in the different frameworks. Look at Symfonies, look at Zen Framework 2s, look at some of the other ones. They have good ones for things like ACL access or even just Boolean access type levels. Please use their stuff. It's far better to say, oh, look, they just did a security patch for this library than to write your own and never see those security fixes because you don't have enough people using it. This is why PHP libraries are so helpful. The other thing people forget is to audit your access to your information. So if you have stuff that is supposed to be limited in scope, please audit access to it. This is an important thing. Audit trails are great for figuring out, I bet we have a hole. Because access to sensitive information like this is one of those kind of hacks that's hard to detect if you're not keeping track of who's accessing what, right? The other thing is to make sure your authentication is correct. If you do authorization absolutely perfectly and you have broken sessions, so these are two things that very much depend on each other. If your authentication is bad, your authorization is bad by default. Now this one is sometimes a little more system level and not always something you can really take care of. But what you want to make sure is that you're not handing out the keys to the kingdom. You're not telling people up front what version of PHP you run down to the point number, so they know exactly that you haven't upgraded and you're vulnerable to this attack. Yeah, maybe they can run a script against you, but it's still more work than just opening up a PHP info page and seeing every setting you have. Anybody here have actual PHP info pages up on their sites? If you want to scare yourself, go look it up on Google sometime. Although, do they have that search blocked? They did after a while. But you could still get it on Google and Bing. Point is, do not give people the keys to the kingdom. Turn off your reporting of your Apache and your Nginx and your PHP versions. Turn off display errors. So my favorite thing ever was going to the Dilbert website, because I work in computers, so Dilbert's hilarious. And they use PHP, and they had a big PHP error right on the front page. I'm like, awesome! And then I wrote them an email, and it was fixed. But the point is, you should always, 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 always have display errors turned off in production. Never, ever, ever, ever let somebody tell you different. The other thing you need to make sure of is that unauthorized people don't have access to your system, right? You need to be careful with things like third-party storage. You need to be careful with storing anything in plain text on the system if it's important. You need to be careful with storing data in a database. You need to know who has access to those systems as the developer. It doesn't matter if you can change who has access, it's important for you to know who has access. If you know every intern at the company has access to go, look up stuff in a database in a query thing, you probably better be encrypting something that's sensitive there. So I'm going to tell you to automate all the things. It will make your life easier. It will make it easier to put fixes into place when they come around. I think it's really good practice to be able to say, oh, this is my dev environment, this is my testing environment, this is my production environment. How many people default to dev environments? Anybody here? Do not do that. Always default to production, because you'll always have that deploy that screws up partway and you want it to say production, I'm not showing anything. The other thing you really need to think about is for your development process, you need to make operating system updates, hardware updates, PHP updates, database updates part of your process. You need to not be surprised when they come, because they are going to come, and you should have a way to deal with that. You should know, okay, we have a new PHP release, so the development servers are going to get it. We're going to run our testing suite. These are the things we found. We'll fix them. Then we'll push it up to the next one. If it's part of the process, it's no big deal. If it's not part of the process, and we have a 0-day in OpenSSL, that never happens. And PHP releases a new version, and you need to recompile it and everything, and you really need to update it. You can have really big problems if that's not part of your process. The reason you make updates part of the process is that so 0 days don't destroy you, because everybody has 0 days. This one I see all the time, which I don't understand. Cryptography is very hard. Anybody here a math major? You are the only one who can do anything with cryptography. It's really, really hard. Unless you know what you're doing, you're going to screw it up. The people who write cryptography generally know what they're doing. So your best practices are do not roll your own. There are PHP libraries. Use the PHP password stuff. The people who have written this know what they're talking about and have big debates on which cryptography version is better. Should I use bcrypt or should I use... Hey, it doesn't matter. Using anything but your own is good. Don't use your own. You don't have to debate which is better. You can let them do that. Use the recommended. Keep your libraries up to date. Bad things happen. Cryptography bugs are found. If you're not updating, you're getting hacked. So the next thing is parameter manipulation. So we have our evil cat. How many of you have ever gone to a site and you wanted to see go up a level and the navigation was crap? So you just like chopped something out of the URL and got a totally different page from what you were expecting? Yes? Everybody here? Remember, users are gonna muck with your stuff. You cannot assume that everybody's coming there from a link you gave them. You need to assume bad things are going to happen. There's a guy named Felipe Pena, and he works on PHP core and does a lot of really good penetration testing and stuff for PHP core itself. But one really cool thing he has, if you go look on his GitHub, is something called a PHP fuzzer. This is really cool. What does a PHP fuzzer do? It takes all kinds of random, horrible, evil data and throws it at you, at your application, so you can see when things blow up. What happens when you pass a null byte in here? Does it go boom, or does it work? So validation properly, types helps a lot with this. Using a fuzzer helps. Whitelisting everything instead of blacklisting helps. Do not ever sanitize things. I'm sorry, strip tags sucks, and it's gonna fail. You can never, ever, ever get all the bad stuff out of data. Do not try. What you want to do instead is escape the bad stuff. You'll have a much better track record with that. Sanitization is the path towards pain. I know I once used strip tags long ago and had a very bad hack on my personal website because I was stupid. Everybody has those moments. What do you do with them? You learn from them. I do not use that function anymore. Finally, let's get into exception and error management. So a lot of people think the big problem with not handling errors and exceptions properly is the fact that it shows data it shouldn't. But you know what the real problem is? Do you know how much memory and how much CPU cycles it takes for PHP to generate an error? Anybody know? It's quite astonishing. And errors are always generated. Even if you have the @ operator in front of them, PHP still goes through the process. So what do we learn from this? Somebody can do a denial of service attack on you by triggering an error over and over again. This is why error handling properly is so important. If you use the @ operator, I will be very tempted to come up and smack you silly. The proper way to fix it, and actually the faster way to fix it, something people don't know, is to stack your own error handler on. Do something with it. Log it. Put it in an audit trail. I don't care. Do something with it. Then pop the error handler back off the stack. That is literally faster than using the @ operator. Do not do that. The other big thing is make sure the user never sees the problem. If you have to have some kind of really evil script to even catch fatal errors if you're doing something evil, I wouldn't recommend it. That's a pretty bad way to go. But I would rather have evil hacky code trying to catch fatal errors than displaying it to users everywhere. This is everything about my server, and see how I'm screwing it up? So log everything. Logs are good. Some people don't like that many logs, but it's usually better to have too much data in your logs than not enough, although you do have to be careful when you log stuff. And why is that? Well, what happens if you log, I've created a new user. Their username is this, and their password is this. Oh, that's awesome to put in your logs. Generally, it's better to be a little less concerned about putting context information as what actually occurred, right? A new user was created. Their ID is this. That's a safe way to log the error. So beware when you are logging and auditing, which we'll get to in a minute, that you're not saving sensitive data, something a lot of people forget. The biggest thing about auditing and logging is don't just write to it and leave it. If you're not actually looking at your logs or your audit trails ever, what's the point? If you only go back and look at them when you know you have a problem, you're not going to see patterns. And what can patterns tell you? Patterns can tell you when bad things are going on. If you're looking at your audit logs and suddenly you see this one user accessing huge portions, like sucking your whole database data out, maybe you should look at that because maybe their account was compromised. Logging and auditing will give you that kind of information. It's worth the time and effort to do it. Although usually you do Composer and you say use monologue and then you say use this and it just goes for you. It's not difficult and it doesn't take a lot of time. So we talked about how you as a developer in your application can look at these most common security problems and what you can do about them. But when we get to this user system layer, I'm sorry, there's very little you can do. Okay? If you ever have to store data on a user system, cookies, encrypt it. Remember, you cannot verify they are who they say they are, their account isn't compromised, anything like that. Their system may be a huge XP botnet. You cannot trust them. They're evil cats. Now, I'm not going to go a whole lot into browser stuff, mainly because I'm running long already. This link, I'll have these slides up later. You should go to it and you should read it. This is an excellent overview of all the security bugs in JavaScript and how to work around them properly. Great, great. There are a bunch of new things that have been put into browsers to help with mitigation of some of the issues, like the HTTP only flag in cookies. You need to make sure you're aware of browser bugs and exploits. Keep your JavaScript libraries up to date. What good is a great updated PHP and Apache if you're using jQuery with a huge security issue? You're screwed either way. Update all the things. So finally, I want to talk a little bit about process at the end of the day. The one thing that I don't see in PHP that I see in a lot of other languages are really great tools to help with security. What do I mean by that? Well, there are a couple different ways you can look at code and try and find security bugs in an automated fashion. One of those is static analysis. How many of you have heard of static analysis stuff? Yeah. There were a couple open source PHP static analyzers, but either they've gone closed source or they're not really maintained anymore. That is a big glaring hole. The other thing is penetration testing. Anybody here know what penetration testing is? Yes. Same concept as the PHP fuzzer, which is the only one that's even remotely close to a pen tester I know about. There used to be some stuff, but most of this is closed source, so you want to pay for it. This would be a great opportunity to make a name for yourself in open source. Yes, I'm recruiting. So those things are something that's really missing unless you want to pay money for them. Now there are some good pay tools for that. Many of you have heard of Scrutinizer? Few people? Look it up, scrutinizer.com. Pay for it. Sensio Labs has stuff for doing analysis as well. They were handing out flyers on it. Go take a look at that. It often helps, especially in very large code bases where a lot of people touch the code, where you have a lot of developer turnover, to take a static analyzer and look through and find some of those issues that maybe you as a developer don't do, but maybe the new junior dev is going to do. Another corollary to that is I think it's really important for all code to be peer reviewed before commit. Unless you're the only developer, it often helps to have a second set of eyes look at everything. Especially for me, because I typo all the time. It's very important to have that extra set of eyes. No matter how great a developer you are, everybody will screw up. We're human, we're not computers. Yet. So these are some security tools I do know about. These are some of the best known security tools. The first one up there is called Skipfish. It does a form of penetration testing type stuff as a command line tool. So you can use it for a lot of websites. The RIP scanner used to be a pretty good product for PHP, but they've kind of been languishing. They started doing a rewrite, and what happens when you try and do a rewrite? Nothing. Yeah, that. OWASP has a couple projects with really good tools. The attack proxy project is really kind of cool. Sticks a proxy in between and attacks your stuff. And if you look on OWASP, they have a whole thing on all kinds of different testing tools. Again, we don't have really good PHP, written in PHP or really designed for PHP testing tools since RIPS is dead. But it's a place to look. And then the last thing there is that link to that threat report. Symantec does one every year. That's a good thing to read, even if just to scare yourself silly or to see where the new attacks are coming from. So these are a little more web application-based resources for you to find stuff. There's testing resources, OWASP, all kinds of stuff. This one's really cool if you've never done a lot of hacking before. This will take you step by step on how to learn how to hack a website, kind of like the tutorial did this morning. It's a great thing to learn. These are more specific to PHP security. How many of you know there's a huge section in security in the PHP manual? Anybody? Has anybody actually read that? Read the frickin' manual. It's really good reading. PHP has some of the best documentation out there. Read it. You will find a lot of places where you can patch holes. How many of you know about phpsec.org? A few people devoted to PHP security. They actually have a document that's given out that you can look at. PHP the Right Way has a section on security. Drupal is one of the, I was impressed with Drupal. They actually have a security section on their site for their developers. Very few open projects devote any kind of time or discussion to security and practices. Then this one here is websec.io, and you should go there. Chris Cornute, the guy who does phpdeveloper.org, started this for web security. He's written a really good book about web security, so if you want a place to get started, if you don't know a lot about this, grab the book and read it. It's a great read. And finally, here's a little bit of information about me. This whole talk actually came out of a rant I wrote in 2011 at the company I was working for because I got really tired of clients going, "Now make it secure." And finally, the last one is my joined in link. This is a new talk, so I'm sure it needs some tweaking. I'm always glad to get feedback on what I'm doing and what you wanted to learn that you didn't learn. And finally, you can find me up at those places. You can also find me on Freenode IRC. I sit in PHP mentoring all the time and in PHP Women. And I'm always happy to answer questions once. No question is stupid the first time you ask it. All right, thank you very much. You have any questions? Yes, no, maybe? What are the slides? The slides will be joined in, but I'm going to put them up on SlideShare. I'll upload them and have the link ready to go. Yes? Worst security hole ever. Worst security hole ever was in me and an open source project I was writing on when I didn't know what the heck I was doing. And I actually put a Git, like directly in a URL. That was awesome. I haven't heard of it, no, so I have no idea. You can talk to me about it later. I may have an opinion. Yes? Documentation stuff. I am a big fan of Markdown because I am lazy. Really, I don't care how you store your documentation as long as you do it. If your team is pretty adverse to any kind of documentation, I'd say text files are the way to go. Generally, I like to have just a docs folder. Docs, security, here's where everything goes. Okay, keep it with the code though. So you know when the code changes, your documentation better be changing too. Anything else? Yes?
Don't like the same color.
No.
So when you, in the situation where you're using filter there to validate your email, validate your training and whatnot, would you not pass the percentage to make sure it's safe before you validate?
When you pass it in, you should validate it just as it is, without trying to clean it in any way. PHP isn't going to barf on that. Okay, it's binary safe. So it'll just pass the ones and zeros and say, does this match? And go no or yes. And then you should tell the user no or yes. In that case, security is a Boolean, though not in general. Yes?
What do you think when you use a particular
You use Remy's repo. Remy Fowler, you use Remy's repo. He does a really good job at maintaining a repo for people who are stuck on Red Hat, on updated PHP and Apache versions. So you are not running stuff that is like, please hack me and take over my server. You fire your employer. No, the other thing that I found works is demonstrating 0 days. Okay, one of the most successful things I ever had with a client is they asked me to add new features. I said, I need to fix the product first. Like, no, we can't afford that. So I did a demo with the president. And in the first form, I didn't tell him that I had backed up and was using a test database. So he thought I did it on the production one. Needless to say, they paid for the fixes. Sometimes you have to hack it to prove that it can be hacked because people won't listen to you. Yes?
Validate data coming from your source. A lot of developers treat that as like, once I validate it with input and store it in there, it's golden.
No. Yes, you need to validate stuff coming out as well. Always. An easy way to do that is to have the validation as part of your escaping. One of the things I tend to do is go, okay, I'm escaping this as, I'm anal, so I'm escaping this as an integer. It better dang well be an integer when I output it. I'm escaping this as a string for HTML. It better be a string. It's often easiest to just wrap that up together, and then you don't have to think about it. Because automating that kind of stuff means less, oh, I just echoed it raw. Anything else? Any more questions? All right, thank you very much.